Hello and welcome. This one now today is going to be solving one-step equations. If you're looking in the book, or you wanted to follow from the book, that would be chapter 2, sections 1 and 2. The Algebra 1 book should be loaded up into my.hrw.com. Again, username hpatch19 and password is Mustangs. So if you want to follow along or use some examples from the book, you could. Our objective here is to solve simple equations just using inverse operations. One step, you're done. Yay! Okay, so kind of go with that idea. Okay, so the first thing we want to look at, let's define a few terms. So that way you kind of know what the heck I'm talking about. First thing we're going to talk about is inverse operations. I'm going to use that term a lot. An inverse operation, think of it as an opposite mathematical operation, such as addition is the opposite of subtraction. Multiplication is the opposite of division. These inverse operations can cancel each other out. So if I have times 3 and I put a divide by 3, they cancel each other out, leaving me whatever is right next to them. So inverse operations cancel each other out. That's very key to helping you solve equations. And then let's discuss what's an equation. Okay, if you noticed on your last assignment, the last thing you took notes on, there was no equal sign. So an equation is a mathematical statement that lets two expressions equal each other. So I'm going to have something on one side and something on the other side, and in between I will have an equal sign. And that equal sign is saying basically two things are balanced. And we'll talk about that more in a minute. So if they're equal, we can figure some things out about them. And then we're going to decide what is the solution. The solution is the number that the variable represents in an equation. So you're going to see a variable, a letter, a symbol in every equation that will represent some number that you are going to find. So that's what we would say there. The value of the variable that makes the equation true is considered the solution. So basically the number that you can find that would for the variable x, y, whatever, that would make the equation a true statement, and I'll show you what that means, is considered a solution. So let's look at this a little bit more. Take this example, x minus 10 equals 4. Okay, that's an equation. Notice I have an equal sign in between those two. Okay, so x minus 10 equals 4 is an equation. The x minus 10 is one expression. It's on the left-hand side. The 4 is considered another expression, and notice it's on the right-hand side. So we have two expressions joined together by an equal sign. And they balance. Think of it like if they were both heavy or they had weight, and you put them on a scale, they would stay even. They would not be so. And whatever you do, if you do it on one side, you got to do it on the other side, so that way you keep them even. If you only do it on one side, well then you're not, and it's going to hurt, and too much. Okay, so we're going to show. Let's look at this. Now again, the idea here is we want to use inverse operations to both sides to isolate the variable and solve. Okay, so again, do opposites. What do I mean by that? Well, let's look at an example. X minus 10 equals 4. Notice I drew a line underneath. What's the opposite of a minus 10? The opposite of a minus is to add. So I'm going to add 10 to get rid of that minus 10, because I want the variable by itself. I want the x by itself. X wants to be alone. Get rid of the 10. Okay, so we get rid of the 10, but if I do it on one side of the equal sign, then I need to do it on the other side of the equal sign. So if I did it on the left, I have to do it on the right. So you're thinking of this as a divider like that. Or actually I should say more like this. Okay, so then the 10 would cancel out. The minus 10, the plus 10 would cancel out, leaving me just x. And then 14, or 4 plus 10 is 14. So there's my answer. Now I can check my work. I can put the 14 in place of the x. So I'm rewriting everything saying 14 minus 10 equals 4. Well, 14 minus 10 is 4, and that equals what I was trying to get it to equal, so everything checks out all right. Smiley face, I'm happy, there we go. So all you're doing is inverse operations. Whatever is the opposite of whatever you see. Okay, so here's a couple more examples. X plus 7 equals 9, x plus 3 equals negative 4. On both of those, let's state what we want to do, the opposite of a plus is to subtract. So I'm going to subtract on both of them. And I'll let it play through, and I want you to see something. So I subtract, I get 2, 2 plus 7, I double check my work, I'm plugging in the 2, back in for the x, everything works out fine. That one's easy. The other one is easy also, but I see a lot of mistakes made with it. I'm going to write minus 3, I'm going to subtract again. So I write minus 3. Minus 3. Here's where the mistake is made. A lot of you will tell me negative 4 minus 3 is 1 or negative 1. They're the same sign. If you see a minus and a negative, think of them as the same. If the signs are the same, you add them together. So 4 and 3 is 7, and they stay negative. So it's negative 7. Okay, and you check your work, negative 7 plus 3. Well, you got a positive and negative, you take away. There you go. I'll let the bell keep ringing. I don't know why they're having that bell go off. I guess it's signifying to say somebody going off to class, I guess. Anyways, some more examples. Here, this is multiplication. You have to identify this is multiplication, so you have to be careful here. The reason why it's multiplication is the only one I don't have to show the operation. You'll see a plus, that means plus. You see a minus, that means minus. You see a divide or a fraction symbol, that means division. Multiplication, you can just put it next to the variable. So you have to realize that, like 4m means 4 times n, and the opposite of multiplication is to divide. So I'm going to divide both sides by 4. When I do that, I get m equals 4. On the other one, I'm going to divide by negative 2 to get y equals negative 6. Notice again that these cancel out, that the 2's, or in these case the side on the left side canceled out, and you're trying to say get the answer from these two. Okay, if there's any questions, let me know. Check your work. You can plug them back in. Notice here I'm putting them back in, the numbers, and I'm letting myself know that by putting them in parentheses, that was where the variable was, and I'm plugging those numbers in place of that variable. So that's how I'm double checking my work. Okay. Again, hopefully no questions on this. This should be fairly easy. Here's the next version, questions. Notice here, I'm saying the variable is being divided. In this case, k is being divided by negative 5. That's what that little fraction symbol means. Fractions mean division. So what is the opposite of division? Multiplication! Ah! Okay, so we're going to multiply. Notice how I write that, and I'm still multiplying both sides. Negative 5 times 4 is 20. 3 times 1.5 is 4.5. And then you can double check your work. So this is actually pretty easy. It's not very hard. It should be something that's very simple. Tomorrow you'll be seeing two-step equations, but right now you're just seeing single-step equations. And this is 2 sections in the book, but it's so easy it should have been combined into one. One last thing, and you'll see this in your notes, is how do I solve this? Because they're going to ask you to do this algebraically, which is what you've been watching. This is algebraically right here. So take that example. X plus 2 equals 5. You subtract 2 and you get an answer of 3. Okay, that is algebraically. Graphically, and I will show you how to do this graphically on the calculator, but you can see here there's 2 lines being drawn here. And I'm looking at that intersection point. That intersection point happens at 3, 5. So x equals 3. Notice I'm going that because I wanted to know when did it equal, when did it equal 5? Okay, so, and then you can look at a table and you can see here, when do they equal 5? Then that answer goes with the x, 3. So there's 3 different ways we can look at that. It's something that I can show you again in class. So if you do have questions about how we can do this with the calculator or through the graphical approach, I can show you. Anyways, that is it for single-step equations. Make sure you have these notes, and I thank you very much.